Hi, welcome to this video demonstration of binary classifier field-aware factorization machine algorithm. So let's begin. On the right hand side, we have the project structure. We have the dependencies, program.cs, sentiment input data.cs, sentiment prediction output.cs, and Yelp label.csv. Since we're using the same training data set over here, Yelp label.csv, most of the program structure remains the same. And I have done that primarily because we wanted to make sure that there is consistency for you to understand the different steps needed for using different algorithms so that you can focus on the algorithms and their specific statements rather than changing the training data set multiple times. And we will look at other data sets in another volume of the series. So in this case, first what we do is look at the dependencies and look at the NuGet package we have. The version installed is 1.1.0, but the current version at this time is Microsoft.ml version 1.2.0. So let's update that version. So we select binary classifier solution, and then we look for manage NuGet packages. We do that and then go browse or select browse and type ML for machine learning, and we see Microsoft.ml, and the current version is 1.2.0, and you have already seen before how to update this package, so I'm not going to spend too much time on it. We're just going to click update, click OK, and we want to make sure that the package has been updated. Yes, it has. It's Microsoft.ml 1.2.0. Having done that, let's go back to program.cs. And so the next step is obviously make sure that you have imported Yelp label.csv data training data set, and make sure it's set to copy always for copy to output directory. And it's similar to what you have seen before in earlier chapters. And we have two classes, sentiment input data model and sentiment prediction output data model classes, and you have already seen the content of those, so I'm not going to spend too much time over here. It's exactly the same that you have seen in other chapters. Sentiment prediction output.cs again is the same structure. Make sure that you import the ml.data library, and then you make sentiment prediction as a subclass of sentiment input data, and you have three properties: prediction, probability, and score with get set methods. So having done that, let's go to program.cs. And so in program.cs, again, you need to make sure that you have imported using system.io, and the machine learning library is Microsoft.ml, and we have Microsoft.ml, ml.data, ml.trainers, and ml.transforms, and of course the Microsoft.ml data operations catalog that we need to reference to the train test data object. So now moving into class programs, similar to the previous examples in other chapters, you have seen we define two paths. One is training data path, one is a model path, and you have already seen these, so I'm not going to repeat too much of that because you've already done most of this. So we have the classify sentiment method declared under main, and the details of that method comes over here. We declare ML context, then we declare training data view using ML context data load from text file, and we specify sentiment input data and pass training data path, hazard or false, and separator character, comma. And then we instantiate train test data object using ML context data train test split, and basically provide training data view and test fraction 0.2 for 80-20 split of the training data set. Then we create the data preparation pipeline just like in previous chapters. We have ML context, transform text, featureize text, and output column is features, input column name of sentiment input data.sentiment text. Then we create the field-aware factorization machine trainer. We use the data preparation pipeline.append method, pass ML context binary classification.trainers.field-aware factorization machine, and in there, let me just expand it a bit, and field-aware factorization machine, and we pass label column name label and feature column name features. Having done that, we create the trained model here, field aware factorization machine trainer.fit, and pass train test data.trainset. And then in step 7, we do the evaluation. That is, we create the iDataView object called predictions for evaluation data view. We use model.transform train test data.testset, and you have seen this before in the previous chapters as well. In step 8, we create the evaluation matrix for ML model. So we use calibrated binary classification matrix ML context dot binary classification to evaluate, and we pass predictions for evaluation data view, label column name label. And then we send some statements to the console as output. We have here binary classification trainer, field aware factorization machine, and the metrics are accuracy, F1 score, area under ROC curve, precision recall curve, log loss reduction, confusion matrix, positive precision, positive recall, and so on. And you have seen many of these already in previous chapters. And then we create a simple sample sentiment text to test our machine learning model, see if it can predict correctly. Then we create the prediction function using ML context model, create prediction engine. We pass sentiment input data, sentiment prediction output, and we pass the model, machine learning model here as part of the argument. And then step 12, we create prediction result and prediction function.predict. We basically use the sample sentiment text here and pass that as part of the predict method. And then we write some console.writeLine statements. We have prediction sentence, in this case prediction result or sentiment text. We use converter to Boolean method to convert binary 1 and 0 into positive and negative. And then we have the prediction probability. In step 14, we use, again, you have seen this before, we create a file stream object, pass the model path, file mode.create, file access.write, and file share.write. And we use ML context model.save method to save the model. We pass the model object, train data view.schema, and file stream. So that brings us to the end of this program. As you can see, all of these programs are very similar and very consistent in terms of how we use them and how to write these programs. Again, Microsoft.ml project team has done an excellent job in making this very simple and straightforward for writing these machine learning programs. So let's run the program to see the output. So we're going to run the program here. So as you can see, the output is already here. We have the trainer algorithm, field aware factorization machine. Accuracy 62% and F1 score 54%. As you can see, the accuracy of this specific algorithm is fairly low compared to the other ones we have seen before on the same data set. And the ROC curves and precision recalls are also fairly low. So again, it shows that each of the algorithm behaves differently given the same data set, and it also is a point to learn that you need to experiment with different algorithms while you train the machine learning model to find the best machine learning model for your given data set. And that is also an important part of machine learning, that is an iterative process that you have to keep on using your different algorithms, maybe tweak your data set to make sure that you are eventually going to get the best trained machine learning model that's possible. We used I love this restaurant as a new sentence for the machine learning model to predict, and the prediction is positive, and it also shows the probability. And so this takes us to the end of the output, and we hope you enjoyed the demo video presentation. Thanks.